Hello everyone, this is the last video of this video series. After a long journey, after 17 videos, end-to-end machine learning project video series is nearly completed, and last step is deployment. After explaining and showing the deployment, I will summarize the whole series. Now let's complete the deployment. I will use Streamlit, which is free and open source and very user-friendly application framework, a Python library. You can use other frameworks, you can develop a browser plugin, it all depends on you. Main goal is developing an application and making your machine learning project visible, interactable, and of course deploying it. Okay, first thing is installing the Streamlit, and it is quite easy. You can use pip command, just pip install Streamlit. I already installed Streamlit, therefore I will not do that, but you can check Streamlit version like that. As you see, I have a Streamlit version 1.14.0. Now let's create a Python file. I'll call it app.py. And of course, we should import Streamlit. Okay. First of all, I will show a very simple example, then we will develop our application. So I will write st-write. Welcome to the phishing detection application. Now let's run the Streamlit application and see what happened. You can use your terminal, Streamlit, run, and the file name. For us, app.py. After running the application, our default browser is opened, and in the localhost, we can see the welcome to the phishing detection application statement. Now when we modify the application file, only thing is refreshing this page, your localhost page. You can easily see the differences, and so I will put PyCharm and browser on the same page. Now we can develop our application and see the changes in the browser. But before that, I want to design my application as mockup. So let's design it together. I will use the excalidraw. Let's draw a frame. Let's think that this is our application frame. I need a header here. Maybe an abstract here. Something like that. Let's call it abstract. After that, we can put project details, but I want to put the project details inside of the expander. So I will call project details. It will be something like that. I want to give some information about the project, but if someone just want to check the URL, if it is phishing or not, then we can just use this expander, because we can hide all details, all information within this element, and it's quite user friendly. Then there can be some input box, and we can say that enter URL. We can get the URLs from the users with this box, and we can also add here some check button. After entering the URL, user can click on this button. Also, users can determine the machine learning model before the checking. So I want to add here some select box. Let's say models. It will be select box. Okay, now let's design the inside of the project details part. So I will use here again. We can add approach and dataset and features, and of course results. We can briefly inform the users about each title, maybe more about the dataset. For example, here there can be data sources, the total data info. You can add also some pie chart about the distribution of phishing and legitimate. Then a dynamic data frame, but get the size from the user. Also download button, download as a CSV, so anyone can just download the dataset as CSV. And for the results, I want to add the results as table and model info. I think enough for this part. We have a good design. Now we can develop this application in Streamlit. Okay, first of all, we need to import some packages. For example, import our machine learning file as ml. Also, we will use feature extraction, so import feature extraction as fe. If you don't know about these packages, you can watch the previous videos. I will use the models from machine learning and features from the feature extraction, so we need to import that. Also, we need beautiful SOAP, so from for I will explain why. To get the content of the URL, I will use request library, so import requests and finally for the pie chart we will use a matplotlib pyplot. Okay, now I want to change this right as title because it will be our title. Welcome to the phishing detection application, and under this title I want to add some abstract according to our design, remember that. So I will use st_write. Here I will write some abstract. Okay, now according to our design we should add an expander about the project details, so I will use Streamlit expander element, and I will say project details. Now we can add our subheaders respectively, so I will use subheader element of Streamlit, subheader approach results. Okay, now let's fill inside of these subheaders. For the approach I will write if you check the Streamlit tutorials, you can see that, for example, like that, you can make this supervised learning as italic. Now for the dataset, I will add some information again here. Now according to our design, I will add a pie chart. It's quite easy. You can implement your graph, any graph, using Streamlit elements like pyplot. In order to prevent a very long video, I already prepared this pie chart and it's quite simple. You can easily understand the labels, then rate according to the size of legitimate rate, sizes, explode figure using subplots, then using pi, sizes, explode labels. You can, all of them are very understandable. And after this, according to design, we should add some dynamic data frame. It's quite easy. Again, use write. In the data frame we have some features, also URL column and also label, so I will give this information here. Also let's add some markdown about the labels. Label is 1 for phishing. Here I will get the size information, size data as input from the user with the slider element of Streamlit, so I will say number equals the slider select row number. It can be from 0 to 100. So again we will use data frame element of Streamlit, and I will use machine learning package to access legitimate data frame. So we will just add number. Okay, according to our design, I will add a download button, and users can get the dataset as CSV with this button. I will use the code block from Streamlit documentation. I will use machine learning packages data frame. then download button. Okay, now we have download button. Under the features, I will add some information using right element. That's enough for the features. Now we can go with results. Again, I will use right element. Here, after this explanation in the results, I will add table, a results table, so we can use the table element of Streamlit. I will use machine learning package and df results. In the results data frame, I will use preparations of the models. So now I will add the longer version of the models here, using again right. Okay, now I will add a select box. Users can choose the machine learning model with this box. It's also very easy with Streamlit because you can use select box element of Streamlit, and I will say please select your machine learning model. Okay, our select box is ready. Now we will use some if-else conditions to select the model. Okay, now most important part, getting the URL from the user. So I will use, I will say URL equals text input, enter the URL, and here I will add try and accept because you know that HTTP connection problems can occur like in the previous video. So try, I will use same parameters in the previous videos. So using beautiful soap, response.content, vector equals, remember we have a create vector commands using soap. I added this because this gives us a vector, but normally we need two-dimensional array for the prediction part. Model predict. Okay, now if result is 0, then it means legitimate, so I will use success element of Streamlit. There are two different cool functions of Streamlit. One of them is balloons, another one is snow. I will use balloons for this legitimate results. You will see what it is. Else, I will use warning because I want to give the message in a red background, red, or I don't know, maybe orange. Attention. Okay, let's look at again. Here we get the URL with using the request library, and then we will check if it is the HTTP connection successful or not. If it is successful, as means successful, then we will create a SOAP object using beautiful SOAP model. Parameters are our content and also HTML parser. Then with this SOAP object, we will use the create vector function of the feature extraction file. Then with this vector, we will predict, our model actually predict the result. If the prediction is legitimate, then we will write this web page seems legitimate. Else, we will write attention, this web page is a potential phishing. We have some fancy functions in here. Of course, if there is any exception, we can see the exception in the console. Lastly, I want to add a button. Remember our design. I will put a check button, and these operations, all of these operations will perform when only check button is clicked. I will add here if button Okay, that's all. Now let's refresh the page and let's check the application. Okay, we have an error, line 120 of running. It should be to CSV. Refresh again. Okay, as you see, I made a mistake here. You cannot see the URL text box, input box, because probably it will inside this. Yeah, I will just modify that part and refresh the page. Okay, this from this part, choices, and yes, this part, all of them should be outside of the expander. Now refresh page. We have a header, we have an abstract, we have a project details expander. You can select the model. As you see, we have some models, and if you select support virtual machine, yes, SVM model is selected. It's dynamic, and you can enter the URL. Let's check it. I will use, for example, linkedin.com. Check. Yes, this web page seems legitimate, so we saw balloons also. We know that LinkedIn is a legitimate web page, legitimate website, so our application predicted correctly. Also, I want to enter a phishing URL. We can add example phishing URLs from our data set, the data source. So I will add here expander for the phishing example URLs with st expand. Okay, now refresh. Okay, now let's try phishing examples. As you see, we have some expander example phishing URLs. Okay, attention, this web page is potential phishing, and as you see, we have snow here. And that's all. We have a cool application. Now we can deploy it in Streamlit Cloud. It's quite easy. The first thing is add all these files to the GitHub. You need to open a GitHub account if you don't have. Also, don't forget the requirements text. You can automatically extract this requirements text file. Then you should register to Streamlit. Let me show that. You write Streamlit to Google, streamlit.io. You should sign up. It's completely free. I already signed up, so I will use sign in button. Here we have a new app button. Click on. Okay, for the repository, you should select the proper repository. Phishing website detection content based. Yes, this is branch. It can be main file path. For example, if you just write something like that, as you see, this file doesn't exist. There's a warning here, so I will use app.py. Yes, now click on deploy. It can take time. Your app is in the oven, yeah. It's running, as you see here, top right corner. Our application is available on the internet now. You can share the link with your friends. They can access the application from their browsers. It's quite easy. Let's check the application. We have header, we have an abstract, we have an expander, project details, approach. Yes, we explained the approach. We added GitHub link, source codes. For the dataset, we added fishtank.org triangle list data sources. We give some information about the distribution of legitimate and phishing websites. Here we have a good pie chart. Yes, this is very good because it's very dynamic, interactive. For example, I can make it 14, and now we have a data frame. As you see, it's from 0 to 13, so the size is 14. first 14 rows can be visible. You can see the values of the features, you can see the URL, you can see the label. You can also download the data as CSV. We have features, brief information about features, results. We have a table. These are the model names, accuracy, precision, recall, scores, the longer version of these abbreviations. And here we have some example phishing URLs. But remember, phishing web pages have short life cycle, so probably we should update it periodically. And here you can select the model. We have 7 models here, and you can enter the URL https one well-known, for example, instagram.com. Check. Yes, we know that this is a legitimate website and our application predicted correctly. We saw the balloons. Okay, that's perfect. Don't forget that accuracy is not 100% in this application, or precision or recall values are not 100. So the application need to be improved. You can improve the application. You have all source code. All of them are available. Source code, data sets, data sources, feature extraction parts, feature engineering parts. Now I want to say what you can do after this, what you can improve as a feature work of this application. Actually, there are so many things to do. You can improve data set, for example. You can increase the size, or you can increase the diversity of the web pages, or you can create your own data set. It can be specific web pages, for example. It can be only e-commerce web pages. And the second one, as you know, I defined HTML-based features. You can add JavaScript-based features. You can improve the complexity of the features. And the third one, I defined 43 features and used all of them. But normally, it is better to implement feature selection techniques such as filtering or wrapper. Then you can use only significant features. It's also good in terms of performance and efficiency. Then of course you can play with models and their parameters, because I use default settings of scikit-learn models. I'm sure if you experiment with different parameters, you can improve the performance of the models. And lastly, as you know, I used only content-based features, so you can add URL-based, domain-based features. Maybe you can build some ensemble models. All depends on you. You have source code, you have data, and you know how to create your own data with this source code. So design your future works and develop and improve this application. Now we are at the end of this long journey. Let me summarize the series with a few words. We started with understanding the problem. I showed how to review the literature. Then we decided our approach and we designed our roadmap. I showed an application to draw some kind of flow diagrams, data flow. And since we decided to make content-based phishing detection with machine learning, we needed web content data. So I showed how to scrape the website content using beautiful soap model. Then we defined content-based, HTML-based features and extracted the features from the content. After that, we collected data and created a structured and labeled dataset. After obtaining dataset and features, we built supervised learning-based machine learning models using scikit-learn packages. We tested models, we implemented key-fold cross-validation, and we received some bugs, some minor bugs. Then we implemented try-except structure, because sometimes websites are not active or reachable. To prevent HTTP connection issues, we checked the HTTP status codes, for example. And finally, we developed an Streamlit application and deploy it into Streamlit Cloud. And that's all. I hope this video series will be helpful for you. I tried to provide end-to-end machine learning project. I explained both theoretical and practical sides of the machine learning. I will be appreciated if you share your ideas, if you give some feedback, and thank you for your comments.